For over 200,000 years, anatomically modern humans, Homo sapiens, with the same physical traits and brain capacity as ours today, have walked this earth. If you took someone from that distant past, cleaned them up, dressed them in modern clothes and dropped them in a crowd, chances are no one would notice anything unusual. Yet for most of those thousands of years, the archaeological record remains eerily quiet. There's almost nothing, no cave paintings, no musical instruments, no ornaments, no signs of burial rituals or abstract thinking, just people surviving, hunting, gathering, and using basic stone tools. Then, around 50,000 years ago, everything changes. Out of nowhere, artifacts of incredible creativity and symbolism begin to appear. Humans start painting deep in caves, crafting beads and figurines, developing complex hunting techniques, and even setting sail to explore islands beyond the visible horizon. The question that has puzzled scientists ever since is, what caused this sudden explosion of culture and symbolic behavior after such a long period of apparent inactivity? What flipped the switch that made humans start acting, well, human? For decades, the dominant theory was that a genetic mutation triggered this cultural shift. Around 50,000 years ago, it's believed that a single change in our DNA rewired our brains, giving birth to symbolic language, advanced cognition, and artistic expression. The gene FOXP2, discovered in the 1990s, became the focus of intense scientific attention. It was linked to speech and language difficulties in certain families, and scientists theorized it played a critical role in human communication. FOXP2 seemed to control numerous genes involved in brain development, making it a strong candidate for what some called the language gene. But in 2007, a game-changing discovery undermined this idea. Researchers sequenced the FOXP2 gene in Neanderthals and found it was identical to that in modern humans. This meant that whatever caused the burst of creativity 50,000 years ago couldn't be explained by this mutation alone. Neanderthals had the same gene, but they didn't leave behind the same cultural footprint, at least not initially. So, the one gene to rule them all theory began to unravel. At the same time that geneticists were re-evaluating the FOXP2 hypothesis, archaeologists began uncovering evidence that human creativity had a much older origin than previously assumed. In Blombos Cave, located along South Africa's southern coast, researchers discovered etched pieces of red ochre bearing intricate cross-hatched patterns. These artifacts date back roughly 100,000 years, twice as old as the supposed Cultural Revolution. Nearby, they also found shell beads that had been intentionally perforated, likely strung together as personal adornments or indicators of social status. These weren't mere survival tools. They were expressions of symbolic thinking. Further along the coast, at Pinnacle Point, excavations revealed that early humans were using fire in sophisticated ways to enhance the production of stone tools and were strategically harvesting shellfish. The earliest layers from these sites date as far back as 164,000 years ago. This evidence showed that advanced planning, environmental awareness, and symbolic expression were not new developments. They had deep roots. The narrative of a sudden leap in behavior 50,000 years ago began to collapse under the weight of these older, more nuanced discoveries. As more ancient sites were excavated, the picture became clearer. What we had long believed was a sudden explosion of culture was actually a gradual build-up that spanned tens of thousands of years. At sites like Sibudu Cave, archaeologists found composite tools made with adhesives and decorated materials, such as painted ostrich eggshells used as water containers. These items reflected foresight, craftsmanship, and symbolic intent. The 50,000-year revolution wasn't the start of something new. It was a tipping point, the moment when existing patterns gained momentum and visibility in the archaeological record. But why had these signs gone unnoticed for so long? Part of the answer lies in geographical bias. Much of the early archaeological work was conducted in Europe, where modern humans only arrived around 50,000 years ago. Thus, the first signs of symbolic behavior discovered, cave paintings in France and figurines in Germany, seemed to coincide with that time frame. But these were not the origins of modernity. They were merely its arrival in a new region. In truth, the roots of human culture were already deeply embedded elsewhere. This Eurocentric view shaped the early narrative of human evolution. Since most archaeological breakthroughs in the 19th and 20th centuries occurred in Europe, the evidence available naturally reflected that region's timeline. It's no surprise that the earliest discoveries of symbolic behavior, like the Chauvet cave paintings or the Venus figurines, were assumed to represent humanity's first artistic expressions. But that interpretation is like hearing a band's breakout single and assuming it was the first time they ever played music. In reality, they had likely spent years performing in obscurity, practicing, experimenting, and evolving their sound. The same is true of our species. We had been developing the cognitive and cultural traits we associate with modernity long before they showed up in Europe. The problem wasn't a lack of activity, it was a lack of visibility. We simply hadn't been looking in the right places. As more regions were explored, particularly in Africa, the timeline began to stretch backward, revealing a much older, more complex story of human innovation and symbolic behavior. Another critical misconception was the idea that Homo sapiens were always the sole torchbearers of intelligence and creativity. In truth, for most of our history, we shared the planet with other human species, each with their own ways of life, tools, and possibly even belief systems. Take Neanderthals, for example. They appeared around 400,000 years ago and spread across Europe and parts of Western Asia. For generations, they were dismissed as primitive cave dwellers, stooped, unsophisticated, and brutish. But that stereotype has crumbled in recent decades. We now know that Neanderthals crafted specialized tools adapted to different environments, controlled fire, and likely used substances like manganese dioxide to help ignite wood. These are not the behaviors of a species barely clinging to survival. They show intentionality, resourcefulness, and possibly even experimentation. Evidence from Shanidar Cave in Iraq shows Neanderthals burying their dead, possibly with flowers or other offerings. While we can't say for certain whether this was ritualistic, it strongly suggests emotional depth and perhaps even a symbolic understanding of death. And just like those early humans, everything we build here, every insight, every story, relies on connection. That's why we've set a simple shared goal, reaching 1,000 subscribers by June 30th. If you believe stories like these deserve to echo further, be part of that journey. Just one click can help keep the flame burning. What's even more compelling is the discovery of Neanderthal cave art that predates the arrival of Homo sapiens in Europe. In La Pasiega, a cave in Spain, red pigment markings have been dated to over 64,000 years ago, at least 20,000 years, before modern humans are believed to have reached the region. These markings, although abstract, suggest a form of symbolic communication or expression. And then there's Bruniquel Cave in France, where researchers uncovered ring-shaped structures made from broken stalagmites, constructed deep within a pitch-dark section of the cave. These formations, dated to 176,000 years ago, were built by Neanderthals over 300 meters from the cave entrance, far beyond the reach of natural light. Such a task required not only physical endurance and teamwork, but also planning, intent, and perhaps even a ritual purpose. This wasn't a spontaneous act. It was a deliberate project. These findings dismantle the outdated notion that only Homo sapiens had the capacity for abstract thought or symbolic behavior. Neanderthals were far more complex than the caricatures once drawn of them. And Neanderthals weren't the only other humans with fascinating capabilities. In the frigid mountains of Siberia, another branch of our human family emerged, the Denisovans. Their existence was first confirmed in 2010 when a small fragment of a finger bone was unearthed in Denisova cave. Genetic analysis revealed something astonishing. The DNA didn't match Neanderthals or modern humans. It was a distinct lineage altogether. Since then, further research has shown that Denisovans interbred with both Homo sapiens and Neanderthals, and their genetic legacy persists today, especially in Melanesian and Aboriginal, Australian populations, where up to 4% of DNA traces back to them. But Denisovans weren't just a ghostly presence in our genomes. In 2019, archaeologists uncovered a meticulously crafted chlorite bracelet in the same cave, dated to at least 40,000 years ago. It featured a drilled hole, likely made with a rotary tool and a polished surface that caught the light. This level of refinement rivaled anything early Homo sapiens were creating. It was art, craftsmanship, and innovation, coming from a species we barely knew existed just a decade prior, long before Neanderthals and Denisovans left their mark. An even more ancient ancestor, Homo erectus, roamed the earth. Appearing nearly 2 million years ago, Homo erectus holds the title for the longest-lasting human species, surviving until about 100,000 years ago, a lifespan that far surpasses our own so far. They were pioneers in every sense, the first to leave Africa, the first to regularly use fire, and probably the first to cook their food. Cooking wasn't just about taste, it had massive implications for evolution. Cooked food is easier to digest and releases more energy, potentially fueling the development of larger brains. But Homo erectus wasn't merely surviving off the land. In 2014, a remarkable discovery was made on the Indonesian island of Java, a freshwater mussel shell dating back 500,000 years, engraved with a deliberate zigzag pattern. This wasn't a random scratch, it was a purposeful design, demonstrating foresight, dexterity, and perhaps even symbolic intent. That tiny carving hints at a mind capable of abstract thought, long before Homo sapiens dominated the scene. It's a signature, not of identity, but of cognition. What becomes increasingly clear is that Homo sapiens were never alone in the realm of culture and creativity. We were one among many human species, all experimenting with tools, rituals, and perhaps even art. Our ancestors weren't the inventors of humanity, they were its inheritors. As more discoveries emerge, we begin to see the human story not as a straight line of progress, but as a tangled web of branches, each contributing something vital. Some, like Homo floresiensis, known as the hobbit for their small stature, lived on remote islands like Flores in Indonesia, and likely created stone tools while navigating complex ecosystems. Others, like Homo naledi, found in South Africa's Rising Star cave system, displayed astonishing behavior despite having small brains. They might have buried their dead deliberately over 200,000 years ago. These actions force us to rethink what intelligence and humanity mean. The criteria we once used, tool use, burial, symbolism, are no longer exclusive to us. Instead of standing apart, we stand among. The past shows us that culture wasn't our monopoly, it was a shared inheritance. What truly distinguishes Homo sapiens, then, isn't just intelligence or creativity, but something more elusive, our ability to scale and preserve ideas across generations. Other humans had the spark of innovation, but those sparks often flickered out. Why? The answer might lie not in individual brilliance, but in numbers. Cultural knowledge can't thrive in isolation. It needs a community. A brilliant idea from one person will vanish if they die before sharing it. In small, scattered populations, this happens often. A hunter crafts a better spear, but without others to learn and pass it on, the design disappears. This phenomenon is known as cultural drift, the gradual loss of knowledge due to fragmentation or lack of transmission. It's the same reason languages splinter and traditions fade in small, isolated groups. During the vast majority of our early history, Homo sapiens existed in low numbers, spread thin across continents. Genetic studies suggest that at times our global population may have dropped to as few as 10,000 breeding individuals. That's barely the size of a small town, hardly enough to sustain complex, shared traditions. But something began to shift between 60,000 and 50,000 years ago. Populations started growing, climate conditions stabilized in some regions, and humans began settling in resource-rich areas like river valleys and coastlines. These conditions allowed communities to remain together longer, forming social clusters where knowledge could be taught, remembered, and refined. With more people came more interactions, more opportunities to trade, marry, collaborate, and tell stories. The likelihood that an idea would survive increased dramatically. Innovations didn't just stay local, they traveled, evolved, and merged with others. According to researchers like Powell, Shannon, and Thomas, this demographic shift was the key to unlocking humanity's cultural explosion. It wasn't that our brains suddenly changed, it was that enough people were around to keep the fire of innovation alive. The archaeological Big Bang wasn't a bolt from the blue. It was a slow, collective build-up, finally reaching critical mass. It was connection, not mutation, that lit the spark. And once it caught, the human story transformed. Ideas thrive when they're passed on, just like culture did tens of thousands of years ago. If you're enjoying this journey through time, help it reach others. Like this video and follow the channel. It may seem small, but it's how ideas survive, evolve, and stay alive. This new understanding reframes everything we thought we knew about the trajectory of our species. For generations, people imagined human evolution as a linear ladder, an ape at the bottom gradually morphing into a modern human at the top, each rung a step toward perfection. You've seen the image. It's iconic, printed in textbooks and memes alike. But that picture is wrong. Evolution doesn't operate in tidy lines. It branches, forks, and doubles back. It's a messy, complex tree full of trial and error, of offshoots and overlaps. Many human species evolved in parallel, exploring different paths of survival and intelligence. Some developed extraordinary adaptations, but vanished nonetheless. Others spread widely, but left little behind. Success wasn't about reaching the top. It was about staying on the tree long enough to pass the baton. Our lineage is just one surviving twig among many that once flourished. We didn't win because we were the most evolved or enlightened. Often, we simply endured. And that endurance wasn't always due to genius. It was helped along by cooperation, resilience, and not a small amount of luck. Take the Neanderthals again. They weren't a failed experiment. They were incredibly well suited for their environment. Strong and stocky, they thrived in Ice Age Europe, hunting massive game and surviving harsh winters. Their extinction wasn't a result of inferiority. It was likely a combination of environmental shifts, competition, and perhaps even assimilation. If the climate had remained stable or Homo sapiens had stayed away, Neanderthals might still be among us. The same could be said for Denisovans. Though we've never uncovered a complete skeleton, we know from their DNA that they were genetically distinct and made lasting contributions to the human gene pool. People of Melanesian or Tibetan ancestry carried Denisovan DNA, some of which aids in high-altitude adaptation. It's like an ancient biological upgrade passed through generations. Even more surprising is Homo naledi, with their mix of primitive and advanced traits. Despite having small brains, they may have deliberately buried their dead over 200,000 years ago. If that's true, it forces us to abandon the idea that big brains are the only route to complexity. And then there's Homo floresiensis, nicknamed the Hobbit, a tiny species just over 3 feet tall that lived on the Indonesian island of Flores. Despite their small stature and brain size, they crafted tools and hunted prey in a challenging island environment. Evidence suggests they may have survived until as recently as 50,000 years, ago, coexisting with early Homo sapiens. These examples rewrite the rules of what it means to be human. Intelligence, culture, and symbolism were not exclusive to us. They were widespread traits shared among our evolutionary cousins. For thousands of years, these species overlapped with one another, sometimes peacefully, sometimes in conflict, and sometimes interbreeding. The human story, then, is not a tale of one group's triumph over all others, but a rich mosaic of interaction, exchange, and shared legacy. It wasn't just Homo sapiens shaping the future, it was all of us, contributing in ways we're only beginning to understand. The very DNA in our cells bears the signatures of these ancient companions, carrying their memory forward in quiet, biological whispers. Today we know that if you are of European, Asian, or indigenous American descent, you carry between 1% and 4% Neanderthal DNA. If your ancestry traces to Oceania, that number could include up to 5% Denisovan DNA. These aren't just genetic footnotes. They're proof that our lineage is intertwined with others. They remind us that humanity wasn't born in isolation. We are the result of encounters, intimate, complex, and often unpredictable. Homo sapiens didn't replace other species because we were smarter or better. We simply had more people, stronger networks, and a streak of good fortune. History could have turned out very differently. A supervolcanic eruption like the one at Toba 74,000 years ago may have brought our numbers dangerously low, perhaps under 10,000 individuals. That's an extinction-level event we just narrowly escaped. We weren't destined to rule the world. We were survivors, resilient, adaptable, and sometimes just lucky enough to persist when others couldn't. That's the real story of our species, not one of dominance, but one of continuity, endurance, and profound connection. So, what truly happened around 50,000 years ago? Why did Homo sapiens suddenly begin leaving behind vivid cave paintings, ornate jewelry, elaborate burials, and the first inklings of mythology? Was it a divine spark, a miracle mutation, or a lone genius in some forgotten cave? As compelling as those ideas sound, the truth is more nuanced. After decades of scientific inquiry and a wealth of new discoveries, we now know there was no singular eureka moment, no solitary flash of brilliance that changed everything overnight. Instead, it was a long and gradual ignition of potential. The cognitive capabilities were already there. The desire to create, express, and wonder had been quietly simmering for millennia. In Africa, in Asia, across coastal caves and forested valleys. The shift occurred when conditions aligned, population density increased, climate stabilized, communities began interacting more frequently, and with that interaction came a surge in cultural transmission. Ideas no longer died in isolation. They spread, evolved, and multiplied. What looked like a sudden revolution was, in fact, a fire that had long been gathering kindling, finally catching flame. Once that fire caught, it transformed everything. Humans began to paint their dreams onto the walls of caves, to bury their loved ones with intention and meaning, to sail into unknown waters in search of new lands, and to imagine gods, spirits, and afterlives. We began to build stories so powerful they would be told for generations, across continents and cultures. We didn't become human because we were suddenly smarter. We became human because we began to share. We built meaning together, carried ideas forward, and wove them into the fabric of our communities. And perhaps most humbling of all, that transformative moment didn't make us uniquely special for all time. We weren't the first to dream, and we may not be the last. Our ancestors, Neanderthals, Denisovans, Homo erectus and others, also dreamed in their own ways. They too left marks on this world, so maybe the question isn't what changed back then, but what we're still becoming now. Our story isn't finished. It's evolving, shaped by the same forces that sparked it: connection, memory, and the will to endure. This redefined understanding of our past invites not only curiosity but humility. It challenges the long-held belief that Homo sapiens were always destined to rise, to dominate, to innovate in isolation. Instead, it paints a picture of humanity as part of a vast, intertwined lineage, a family of explorers, builders, and thinkers who each carried pieces of the human story. We didn't stand apart from the others, we stood among them. Our survival was not guaranteed, and our triumph was not assured by superiority. It was enabled by a delicate combination of adaptability, interdependence, and time. We inherited a legacy of learning that spans continents and millennia. Each engraved shell, every ancient burial, and all the pigments used in the dark recesses of forgotten caves whisper the same truth. Humanity is not a spark, but a flame passed hand to hand. And when we tell our story, we are telling theirs too, woven into our genes, preserved in our myths, and echoed in our most enduring acts of creativity and compassion. So when we ask what made us human, the answer is no longer confined to a single gene, place, or moment in time. It lies in the countless exchanges between individuals and communities across thousands of generations. It lies in the quiet resilience of those who lived, loved, and learned in an unpredictable world. It lies in the realization that being human isn't just about brain size or tool use. It's about the ability to remember, to teach, to wonder, and to adapt. We are not the peak of evolution. We are its current voice, shaped by ancestors whose names we'll never know, but whose presence lives on within us. Their ingenuity, endurance, and dreams made our world possible. And now, it's our turn to carry the story forward. We are still evolving, still becoming, as long as we continue to connect, to care, and to create. The fire they kindled will never go out. It will light the path ahead, reminding us not just of where we came from, but of what we're capable of becoming together. And now, I'd love to hear your voice in this story. What part of this journey struck you the most? What made you pause, reflect, or wonder? Drop a comment below. Your thoughts help shape the next chapter, just like every human before us helped shape the last.